I'm very happy that he's here today with us. He's a frequent visitor of IAAC, a very good friend of us. He's also this year guest faculty at the Master in City Technology. And we're also very happy about this because Carlo Ratti, apart from all the work that he's developing in his practice, Carlo Ratti Associati, he's also director of the Senseable City Lab in the MIT. And he was one of the first people that started to speak about the influence that the urban environment has with the new technologies of information and communication. So he has been working many years on understanding how design can contribute into overlapping real-time data and understanding those technologies in a physical space. So from very small scale, like the Copenhagen Wheel, that was collecting real-time data about the environment, to big-scale projects like the Singapore Live that he has been mapping in real time, for instance, taxis. I don't know if I am doing the lecture for you, hope not. But a great project where he was trying to understand how he can contribute into the traffic of the city and how he can optimize the mobility of the taxis in relation to where the flow of people is. So real-time data matters, and the fact that we have now the technologies and we are able to collect them, it means that they are becoming a big and important tool for designers in order to design. So Carlo has been nominated as one of the new minds to change the design, and he's a kind of a pioneer on that aspect. Carlo, thank you so much for being with us. Thank you for contributing into our new Masters in City and Technology. As an expert on city and technology, that is really, really important for us. And the floor is yours. Welcome, and please help me welcome him.
Thank you. Thank you, and good evening, everybody. It's a pleasure to be back here, and also, thanks to all the people who were part of the workshop that we did the past four sessions. So I just wanted very informally to share with you some of the work we've been doing. Let me see how. Well, I'll do it from here. I don't like to sit. Can you hear me? Can you hear me? Yeah. Wow. All right. Okay, so I just want to share with you a few things we are working on, we've been working on, and then hopefully have more like a conversation. But I want to start with this picture because people used to be really fascinated about this in the 1990s, about a world that would become increasingly digital, and hence, they thought, increasingly virtual. So much so that many people at the time thought that actually cities themselves might disappear. This is Gilder 1995, thinking that because of digital, because of the internet, space would be less important. He wrote, "We're headed for the death of cities. Cities are leftover baggage from the industrial era." Well, what does this tell you? The first thing it tells you is, don't never make predictions, because no prediction could have been more wrong than this one. We know the cities have been thriving. This is a picture from China. I think there's a bit of echo. There's a picture of China. China itself is building this century probably more cities than all of humanity ever built. We know that since 2008, half the world's population is in cities, and this number might swell to 5 billion by 2030. So what has happened is that digital hasn't killed physical space, but digital and physical kind of recombining and creating a new hybrid dimension in between bits and atoms, with us in the middle, that really is changing the way we understand, design, and ultimately live in cities. Let me give you just one example. If you look at this, is the progression of mobile connections on the planet from the beginning. Now, it might seem surprising today that there was a time without mobile connections. It was just, 1979. It was the first worldwide, the first in the world mobile network in Japan, developed by NTT. And it took 20 years to get to 1 billion, and then 2, 3, 4, 5, 6, 7. You might say there are 7 billion people on the planet. How much more could this grow? Well, according to the latest prediction, we're just somewhere here, and then we'll be at 50 billion by 2020. And the reason is that we started connecting people with people, and then people with data, people with data, and more machine-to-machine things talking to other things. Creating a lot of sensing ability in the city, the ability to sense things and to respond to that. Almost as if every atom out there of physical space were becoming a sensor and an actuator. Now, if this is the framework, let me share with you just a few examples both about sensing, how today we can understand the city in a different way, and also actuating, how we can respond to that. If you look at this, we couldn't see a city like this just a few years ago. That's the city of Lisbon. It's a visualization that was at MoMA, the Museum of Modern Art in New York. It was done by Pedro Cruz, who was in our lab at MIT. The way this is done is by using billions and billions of data points from the taxi network, from GPSs, and then actually mapping them and looking at the city like a living organism. I'll show you another example, which is now very old. It's like 10-year old. But I thought I'd show you nonetheless. It's 10 years ago, in 2006, we had a pavilion at the Venice Biennale, exactly this time of the year. And in that pavilion, we did something that hadn't been done before, was to take data from the whole city and actually use it from the cell phone network and use it to understand really how the city lives, to understand the metabolism of what is happening in the city. The city was the city of Rome. In 2006 was quite an interesting year when there was a final of the Soccer World Cup. And I'll show you a little clip that's taken from the monitoring we were doing in Rome and showing at the Venice Biennale, the day of the final of the World Cup, when Italy actually won. So here you can see before the match, you see people moving here and there in the city of Rome. It's the afternoon. In a moment, the match begins, silence. Nobody talks anymore. France scores, Italy scores. Halftime, people make a call and go to the bathroom. Second half, end of normal time, first and second overtime. The famous headbutt by Zidane. Remember Zidane? And finally, Italy wins. And then that night, everybody goes to celebrate over here. And then you can keep on following what happens the following day. How really you can capture the movement of people. That was the dream of many people. It was the dream of Serdar. If you read some of Serdar's books, he said, I wish I had the data from the city that would allow me to. There's some kind of bit of echo. Okay, maybe better. Yeah, I think it's better. Yeah, that's it probably. When Serdar did, he said, I wish I had the data to really turn urbanism into something more scientific. And today we actually can do some of that. We can look at space around ourselves in a new way. That was also a project we did at MoMA in New York with Saskia Sassen. We look at the connections of cities around the world. What you see here is New York and how it connects with all the global hubs. See Africa, just a few spots there. It's Joburg and Cape Town. There you see Australia. So basically how flows of information happen on the planet. How we can also use sensors to capture a lot of this movement. In this project, for instance, starting from this machine, this computer, and looking at the fact that today you know everything about this machine. Every chip in this machine, you know where it was produced, how it moved on the planet, how it became this computer. So now you stop using it, you throw it away, and then you know very little about it. Sometimes electronics is shipped illegally to developing countries, from Europe to Africa, from the United States to Asia. So we decided to develop a little chip to put on trash and then start following trash to see where it goes. This is the first deployment we did in Seattle. We had 500 people, came with 3,000 pieces of trash. We put a little tag on all of them. And after tagging all of them, we started following them. So here you can see the day of deployment. After a few days, you see some of the main landfills next to Seattle. But actually a big surprise, how far stuff started to travel, sometimes in crazy, unexpected ways. Look at the trace that went to Chicago and then changed its mind and went back to California. And still moving after 1 month or 2 months. Actually, just last week, we did a follow-up of this project. It is something that we started working 3 years ago. And then when we did the first project, we realized that a lot of stuff from the United States would end up in ports. So the way that the tag works is like this kind of miniature cell phone, gets location and sends it back. And then we had only US-based SIM cards. We didn't have international data plans. And we realized that in some ports, stuff would actually then disappear. So we actually did a follow-up where we looked at e-waste globally. So we did the same thing, but with tags that can cover the whole planet. And then those are some of the things we discovered. This was just revealed a couple of weeks ago. There's an interesting PBS. PBS is the American public TV service that looked at this in detail. They went around the world to search for what we found. We collaborated with others. We gave our technology to a non-profit that actually deployed it on many, many pieces of e-waste. And what we found was something like this, which shows you all of the illegal smuggling of, some legal, some illegal smuggling of e-waste from the United States. You see shipped to Asia, entering Asia through different ports, and then moving through Asia. Again, some of this is legal, some of this is not legal. But if you're interested, you can find some of the results online. We just did this, made this public a couple of weeks ago. What you can do with this? Well, the first thing you can do is, if you are a planner, an architect, an engineer, you can look at all this data and see how we could design a more efficient waste management system. So how we can use all of this in order to do what was done to the supply chain over the past decades to make it more efficient, but to do it to things once we throw them away. The second thing that's very important is that data itself, if you give it to people, can promote actually behavioral change. Data means big data means we know more about the city around ourselves. We know more about the consequences of what we do. And because of that, we can change our behavior. Something interesting, at the end of the project, somebody came to us and said, I used to drink water in plastic bottles every day and then throw them away and forget about them. But now after the project, I know that those bottles go to a landfill just a few miles from home. They will stay there forever. So because of this, I changed my behavior and stopped drinking water in plastic bottles. The third thing we discovered was more unexpected and happened recently when a burglar came to our lab at MIT. And the poor guy stole a lot of things, including tags and computers that tell you where they go. And this is what happened. All right. Well, so this is to share with you how we can get so much more data from the city. Sometimes because we collect it from taxis, from cell phone networks, by deploying tags. So all of this become a great wealth of information we can use. And from the data itself, just by analyzing, we produce interesting things. This is again what I showed before with Lisbon. And if we analyze it, for instance, you can see that a lot of trips can be shared. And that is what, for instance, led to a project we just did, where we looked at the shareability of trips that then started a collaboration we have now with Uber and with Uber Pool about really how we can reduce the amount of trips in the city by combining them. And then, you merge two trips together, you share a cab, as you do with Uber Pool, and then you create a more efficient, sustainable, and less polluted city. And about pollution, I want to share with you, sometimes, we can put tags on even on trash, so we can put it even on our bodies to measure, for instance, pollution as we move through the city. In this project, we looked at pollution in China. It's a big issue, air quality. And we looked at Shenzhen and Hong Kong. It was recently at the Hong Kong and Shenzhen Biennale. And look at, by the color of the picture, how different air is on one side and the other side of the border. All right, but so all of this is about the city and how we can collect data from the city. So how we can sense the city in an interesting way. All this information we can get because somebody collects it to run a network, or because we use sensors. How we can know more about the space. But then the key question is, how can we actuate? How we can use this information to respond? And that was really one of the first things I did when I got to MIT. One of my first projects was this project. It was just a sun table. You still find some videos online. In this sun table, you can change with your hands. You could change the surface. You get a 3D scanner on the top. We would take a picture constantly of this kind of three-dimensional surface, and then you could get information in real time about the surface. So if you are a landscape architect, you can actually look at waterfall, at slope, and other things. It's like a magic model. You change the model, and then you get the information in real time over there. When we were doing this, actually we had a dream. And the dream was, what if one day sand itself could move? And we tried to do it, but this was around 10 years ago, and we couldn't succeed. Around 10 years ago, it didn't have Arduino, electronics was difficult and clunky, motors were too big, so we didn't succeed. So it was quite refreshing to see that last year, Hiroshi Ishii, a couple of years ago, Hiroshi Ishii actually still with the same thinking, managed to turn this into reality and to make the sand dance. And if you look at this, the person is not there, so the person is actually elsewhere, but you scan the person, and then information is captured again in 3D and is transferred over space. So you see now the person from the back. He's remotely, but actually you're scanning in 3D that information, and then you send it over the internet, and then you can transfer it. So it becomes like a living, like dancing atoms, like a living material. Well, I mean, you got the idea. And just a few weeks ago, what we did at the Milan Design Week, this is one of the first times I'm showing this. We tried to do something similar with Vitra, on a bigger scale, but we initially wanted to call this almost like a tribute to Hiroshi Ishii. Vitra is a furniture house based in Switzerland, and this installation that was presented at Design Week this year, so just last month, and is still visible until September, was based on a similar idea. Can we create a space around ourselves that can change shape in a very flexible and dynamic way? Imagine you've got those hexagon, and then they can move up and down, so they can allow you to create any responsive surface around yourself. Here is a little video. So in this way, it's about, how you can use Internet of Things to make things more responsive. But sometimes you can also do something more low-tech. In this project, for instance, this was with Cassina, an Italian furniture producer. This was also recently. They came to us and to Philip Stark with the same question. Philip designed this sofa. We designed this element here. But the question was, a few years ago, you'd go home, you sit on your sofa, you'd open the newspaper and you read it. Today you go home, you go and sit on the sofa, on the couch, and you might work with your iPhone. You might need to send emails. You might need to read your newspaper, but actually read it digitally. So the question was, can we have something that's both a coffee table like this, or can become like a place where you can check email, post on Facebook, do other things on your tablet or computer, or a place where you can entertain friends. And this was the initial concept that, of course, Cassina said, sure, that's amazing, that's wonderful, but, how you do it? There's no material that allows you to do it. But we had half an idea of, that maybe there was something we wanted to experiment with. And we started thinking about this. So if you laser cut elements like this one, and you laser cut every element slightly different than the other one, in a parametric way, you can mathematically define shapes that are stable under different configurations. So from this and combining many of this, you can create something that's stable like this, or in other shapes. Yeah. Yeah, I think this is better. Okay. Yeah, apologies. It was a bit annoying for me as well. Now it's not much better. Can you hear me well? Good. Okay. All right. So basically, you can imagine shapes that can do all of this. And again, today it's quite simple to prototype something. You know it very well, just next door with a Fab Lab. Got an idea, just cut it, laser cut it, or 3D print it. This was the first thing we did. Pretty ugly, but actually it was working. This was the open version. You close it, and you do it like this, so you get all these stable configurations. Then we started working with wood and metal, so combining them. You see here a second test. That's a machine exactly like the laser cutter you got there, but it's a bit bigger. You can also use it to cut aluminum. And then you got all the different elements. You cut them, you assemble them. And here was the first prototype. still a bit thick. Now we can do it much thinner, but then we can basically do what we were seeing before. It can be closed as a coffee table, open up just half, or open up in a more in a communal way for sharing with friends. And actually, this year at again at Design Week, we won a competition with a project that uses a similar thing but takes it in a different direction, but the same concept about how can you look at shapes that create different stable configurations geometrically. They create this tool, and I'll show it to you. From next month will actually be open source. You can download the files if you want and build it. But based on the similar principle with a different application. You see it here. So, a lot of our work and our effort over the past few years has really been about, can we create an architecture that responds to us in a more dynamic way? Can we interact with space around ourselves in a similar way to the way we interact with each other or with animals, with living things? And these were some examples about at the sofa, or how we can build pieces that create different configurations. This is a project we did also at the Venice Biennale, where we looked at projections. In this project, we looked at a special projector that's like the one you got there, but in front of it, it has a digitally controlled mirror that allows you from one direction to project all around yourself at 360 degrees. And so the idea was, can we create an architecture, a geometry, that will maximize the co-visibility of surfaces so that every surface could become alive, in this case, through digital projection, like this surface or this other surface. This was the plan, really design co-visibility of surfaces. You could keep it off so it would still be an exciting space to live, but then you turn on the projector and then all of the surfaces could become like a living one. The same thing you can do actually not necessarily with digital projections, but with heat and cold. Today we actually use a lot of heating in our buildings, even when they are not used. Think about your homes. During the winter, you put a lot of heating during the day when they're empty. We're in the offices. And same with the offices. We are heating the offices during the night. When they're empty, we're at home. And that's a scientific article. We looked at this on the MIT campus, and we really, in a quantitative way, we looked at this about the fact that there's between where we put heating and cooling and where people are. We use a lot of energy to heat and cool, or even light empty spaces. So we started thinking about, what if in the future we could actually think about heating and cooling that follows you, like a bubble of heat that follows you. And that bubble can also be the temperature that you want. It can be in 18 or 20 or 25. You decided, and this bubble follows you. We did the first test outside MIT. That's the main entrance, 77 Massachusetts Avenue. So you step on the carpet, and then this bubble of heat will start following you. People loved it. Some people freaked out. It had this kind of laser beam that would keep it at a certain temperature. In the last Venice Biennale, the one a couple of years ago, curated by Rem Koolhaas, Rem gave us a space in order to prototype this. I showed the little video of making that installation, where a lot of emitters in the ceiling will create this bubble of heat that follow people and track people as they move. And of course, you can think about this done with heating, but the same thing you can do with cooling. That's a project we did with the office just a few months ago. What you see there in one of the shadows is Sheikh Mohammed from Dubai. And this was like a little cloud you mist, so you cool the air by using misting, but then the cloud is responsive, so it follows you as you move through space. For those of you who are Italian, it's a little bit like the cloud by Mr. Fantozzi, that follows him all around. And so this is the same thing, but digitally will keep you cold. Dubai. A big problem in Dubai is that public space cannot really be used. During the summer, it's too hot, and you cannot air condition the whole city. So if you do this, you bring back people into public space with very little energy, just creating a small bubble around where they are. Another thing I want to share with you, again, we are going to bigger scale, but still the same principle of how the space around ourselves can become more responsive, is a project we did for the World Expo in Milan. At World Expo, we were fortunate enough to do 2 pavilions. One pavilion was this one over here. We did not do the box. This kind of shoe box was given to us, but we were given the freedom inside to transform it. And the brief we were given for this pavilion was about a supermarket. The expo last year, you might have heard about it. It was about feeding the planet. It was about product. And in this district, which was the district about the future, the idea was, how is the supermarket going to evolve? How are we going to buy products in a different way in the future? Well, we did know what we did not want to do. We did not want to do this. It's a beautiful picture, but it's an alienating picture. It's a picture by Andreas Gursky. It shows you supermarket of the 20th century. But it's alienating the way that, all the products really are, there's no humanity there. It's just, all this immense amount of products, one on the top of the other. What we liked was the following, and that's a quote by Italo Calvino, an Italian writer. And Italo Calvino you might know because of Invisible Cities, but he also wrote a number of short stories with this guy called Mr. Palomar. And Mr. Palomar is this guy who's a little bit aloof and goes to different places and always has a different take on the world. A little bit like in Invisible Cities, Calvino pushes the boundary about how we look at the city from one dimension, and he distorts it, almost in a magic realism way. In a similar way, Mr. Palomar looks at the world from his own perspective. And Mr. Palomar once goes to a small cheese shop in Paris, to a fromagerie, and Calvino says that the guy starts thinking like he's at the Louvre, because he starts looking at all the stories behind the piece of cheese. Every piece of cheese, Calvino says, tells a story about the pasture, about the sun, about where it was made, about the civilization where it was coming from. And so our idea was, can we actually make this information accessible when you go to a supermarket? If you think about it today, take any bottle of wine. You know everything about it. You know the vineyard, when the wine was made, when it was bottled, when the bottle got to your desk. But all that information is not there when you are in the supermarket. So can we actually bring that information back to the supermarket? And of course, this question is not a new question. Many people try to look at this. If you look at this, there's something that Tesco, a big UK-based supermarket chain, did. This was in Seoul. And the idea was, you take your phone, you scan the product, and then you get information about the product, and then you can order the product. But if you look at this, it was a total failure. And it's no surprise. It stayed there just for a few months, but it's no surprise because, again, it's alienating. There's no interaction between humans. It's just you and your phone and scanning something. There's no richness of interaction between people and products and other people. What we wanted to do was, is there any way we can use technology to do something different? We can use technology to go back to something like this. It's a painting by Guttuso, again, an Italian writer. And look at the richness there of how people can interact with each other through products. Look at the richness of the market, where it's a convivial experience, where we learn a lot of things about the stuff we buy, the stuff we eat, and about each other, about what each of us will pick. So the way we tried to do it was by putting everything on big tables. We think that the table is a great interface. We have used tables for thousands of years as a way to share things, to eat together, to sell things. So it's a very communal interface. And at the top of the table, we put a lot of these things, which is the well-known Kinect, which is the same sensor that you've got in the Microsoft Xbox. And what it does a like very quick and cheap three-dimensional scan of your body. So you see how you're moving and what you're engaging with. And we will actually look at what people would touch or point or engage with, and then seamlessly give them information about that. So here, this was one of the initial sketches. You just touch an apple or point to an apple, and then all that information will seamlessly get to you. You know, again, this allows you to buy an apple like today in just 1 second. You take it and you're done. Or if you got a few more seconds, you can engage with it a bit more and know more about nutritional properties and so on. Or if you still keep engaging it, you can get even more information, like, you know, the video where the apple is and other stuff you might be interested in. Well, this was a supermarket. It was done in collaboration with Coop, one of actually the biggest supermarket chain in Italy. And we also did a slightly sloping that was retrospectively was a good idea, because then from the top, you enter from the top, you see all this kind of amphitheater of products. You see all of them together. And then when you will engage with the products, you'll see just all this information that seamlessly would appear. And then here above, you got more aggregated information. So here you have information about the thing you're interested in, but above, you will get information about the most popular thing of the day, about the special offers, about things that aggregate information, big data aggregated at the supermarket level. Because, you know, there's something interesting that if you do this, so if you look at where people are to give them information, then on the other side, you also know what people are interested in. So you know a lot about our interaction with things, what we like. It's almost like what everybody does online, which is monitoring clicks. You know what people are clicking. Here you can do it in physical space. Built supermarket. So this was it was the finished thing. We had also some robots for reshelving. You see some of the other spaces. It won a number of prizes, and actually now it's leading to some real-world developments. The interesting thing about the Expo is that you can test things, but then you can learn from them. And with millions of people, with a few million people who were inside the pavilion, you could really buy and shop over there. It was a real supermarket, and then from this information you can turn it into the real world. And kids love the fact that you could run and have like an accordion of information opening up and following you. In the same way as even rather old people could engage with it without caring about the technology. Something like the technology is there, but it's seamless. You don't need to think about it. It just comes to you. Here's a little video. All right, and I wanted to finish with a couple of things. This is the other project we did at the World Expo in Milan. In this case, we won a competition for a company called New Holland. It's one of the top 2 producers of farming equipment in the world. It's John Deere and New Holland are the 2 top producers of tractors and farming equipment. And in this case, we were interested about self-driving. What you see here is a self-driving car. The 2 little ears that you see are like the eyes we use. They do a 3-dimensional scan around ourselves, and they use that in order to navigate just with artificial intelligence. But self-driving cars are a reality. You can buy today self-driving cars that goes up to 35 kilometers an hour. But if you buy a Tesla today, Elon Musk promises that he will do software updates so that tomorrow will be totally self-driving, even at higher speeds. So the technology is basically right. But if you can do self-driving cars, what about self-driving tractors? Now, tractor is even easier because moving on a field is relatively easier than actually moving inside a city. Today we have tractors guided by GPS, but not self-driving tractors. Is that if you do self-driving tractors, you can think about something very different. And that was the sketch that we used for Expo that won us the competition for New Holland, which is if you got tractors that move in a self-driving way over space, then you can imagine about going away from monoculture. Sophisticated. You can think about a tractor that moves like a little robot over space, puts different seeds in different places, and then you farm again in a location-specific way. You grow and you harvest things in a different way. So what you're doing is effectively moving away from monoculture. Absurdity for nature. Monoculture is terrible for nature because it's not a rich ecosystem. It's just one thing which is very vulnerable. But in the 20th century, we could only do monoculture. You can go from that into something much more sophisticated, which is putting different seeds in a more mixed way, in the same way as nature would do. It's almost like printing at the agricultural scale, at the landscape scale. Now, this was the idea we had for the pavilion. And I'll show you now actually something that was done as a test that was done by Benedict Gross, who was in our lab at MIT, and they did it as his master thesis at the Royal College of Art in London before the Expo. This was the idea. Imagine you have just two crops. What would nature do? Well, most likely might do something like this. It doesn't matter. You can print any pattern you want. But think about a cell-based system, which is what we find a lot in nature. And then here you can see really what he did was actually develop a tracking system to allow the tractors to move, and then all the way to printing at this scale and then harvesting. Here's a little video. And so here you see exactly what we saw before, basically almost like printing at that scale. You see the same shape you had before that then has become different crops over the landscape. And I wanted to finish with one more project. Again, it's an Expo project, but this time it's closer to a year. It was the Expo Zaragoza, one of our first projects that was back in 2008. And the mayor of the city came to us and said, all of this is great, how we can make an architecture that's more responsive. What could we do with water? And the reason is that actually Zaragoza, the theme of the Expo, was water. And so we thought about it, and one of the ideas that came up was, imagine you have a pipe, and on that pipe you got many tabs controlled by a computer that open and close and create a lot of drops that then you can control digitally. So if you do that, you can create like a digital water wall, a place where it's a living wall where you can show text or images or patterns, or you can open up when you approach it, like here. So the mayor liked the idea, so we got the commission to design the building at the entrance of the Expo. We called it Digital Water Pavilion. All of the walls are made of water. You can show images or text or patterns on them. No doors or windows, but when you approach it, it opens up to let you in. And then when you're inside, also the walls expand and shrink based on how many people you have. So the cafe space will become bigger or smaller. The roof is also covered with a thin layer of water. What you see on the back is Zaha Hadid Bridge next to us at the entrance. The entrance of the Expo was really here, and then you cross the thing. And then if you got too much wind, you can lower the roof to minimize splashing. Or at the end of the day, you can close the building, and the whole architecture disappears. Hopefully without anybody underneath. sensors for that as well. So we did this. We had a lot of fun doing this for the mayor's office. To be honest, totally honest with you, we did not think that they would build it. But then what happened is that like 6 or 9 months before the opening of the Expo, Time magazine in the US named it one of the best, namely best building of the year. And so we got the commission to do it very quickly at the end. You see here the building. You see, these were the tests before the opening. I like this picture because you see the guy had a trolley and was actually going to the station, but stopped there to say, what the fuck is happening here? He couldn't figure out what was going on. Here it was actually the projections of double water. So it's about the water wall, the physical pixels and the luminous pixels on the top of it. Here it was myself trying not to get wet. And basically you got all the sensors that detect people, and then based on that, the water will open and close to let you inside the building. And well, I should tell you now what happened one night when all of the sensors stopped working. And we do a lot of buildings that are more like computers that become very sophisticated, but sometimes computers crash. And that night we were terrified, because that night the building would keep on doing its own crazy things, like cuts and holes and writing and so on, but without responding to people anymore. But actually that night turned out to be one of the most fun nights ever. That night, thousands of kids from all over the city went to the building to play a new game. Not anymore a building that opens up when you approach it, but a building that you need to approach like this. By the way, I'll tell you something else. That night the building had been hacked. So if you look at the text, also what it says, the things on the water, it says. Sorry, what's going on? Come on. Okay. Anyway, and having said that, for us it was a big lesson, because as architects, engineers, we always think that we know how people will use the stuff we design, but then reality, and especially human reality, is always a surprise. In this case, it was a good surprise. Thank you. And I kept the presentation a bit shorter. I really wanted to share with you some of the experiments we've been doing. Really, the common thing is how can we build an architecture around ourselves that starts behaving like us, in a certain sense, the response to us like a human would do, like a biological system would do. But it would be great to hear your views and comments, questions. Just raise your hands, and we got microphones going around.
I was about to say the same, so you did it already. Thanks a lot, Carlo, for your lecture. So let's see if our students and guests are curious enough.
Yeah, there's a hand here.
Hi, I love your ideas, and I remember when you presented the 10 years one. I saw your presentation 10 years ago. But anyway. What is the reaction sometimes when you raise based on your data? For example, the garbage that was not a good information to be sent out, and also the pollution in China is how sometimes even the media react, or even what happened when those glitches on society happens based on your project?
I think it's a great question, and I think the question I would frame it a bit more about what is the role of design. The role of design, if you had asked 100 years ago Le Corbusier about what was the role of design, well, his idea and the idea of the modernists was very clear. He had one solution, and you just had to impose it on society. And we think that role design should be something very different. And the role of design is more to try out something that shows how the present could be transformed. There's a great sociologist, economist, also, he won the Nobel Prize, called Herbert Simon. And Herbert Simon once wrote that basically science is about how the world is, design is how the world could be. And so in this idea of how the world could be is the potential we have to transform the things around ourselves, sometimes to use science in order to transform the space in our cities or the space around ourselves. Now, if that is the starting point of design, how design can help us to transform things around ourselves, then we think that our role as architects, as designers, our role at the lab is the fact of seeing potential transformations of the present, but then the decision should be ultimately by society. And from this point of view, it's very important then also that you have this feedback. And media is also one way to have feedback. I mean, we are happy when a project goes viral, just because that's a way that you get a lot of feedback. It's a way that you have a proposition. You say, well, what about this? And then there's a discussion about this thing you're talking about. So going back to your point, what is the role of, you mentioned the glitches or the media into this? We think it's important because it's part of the feedback. It's about thinking about us as designers, like all of us, all of you, all of us. Not as people who have a solution for something, but we are people who can propose something. Sometimes use science to propose that design solution, and then we can have a conversation about a solution. So it doesn't mean that society has to go there, but that's certainly a possibility we want to discuss together. And I think this is a very different way to think about design than the 20th century way, which was very deterministic. It was, this is the solution. It's more about this are possible solutions, and we can together decide where to go. If you want, again, it's similar to what nature does. Point of view. What nature does is actually do mutations, and that some of those mutations will be more successful than others. So I would say, think about ourselves as kind of mutagens, proposing mutations in the artificial world, and then let them grow thanks to the feedback of society. And in this feedback, again, the more there's participation, if the media is part of that, that's great. It helps to really have a discussion. You want to? Oh.
Go ahead.
Okay. You said at some point that our buildings will become computers, right? And
So sorry, say it again.
you said at some point our buildings are becoming computers now, or are becoming kind of like augmented electronically. To which extent we can open source our designs, and in the light of Aaron Swartz and the open source movement and all of that.
Yeah.
To which extent do you believe that we should open source the design?
Yeah. It's a great question. Now, there's two questions here that I would like to answer them separately. One is, can we open source design, and what does it mean? And second is, should we open source design? So on can we open source design, yes, we think that is quite exciting the way we can today open source several things. Now, you can open source in different ways. I mean, what I was mentioning just a moment ago about getting feedback, about discussing a design, is another way to open source it. It's just a way, open source it. Open source it means many things. It can mean that you actually take a design, like the design of the stool I showed you before, that will be put on Creative Commons next week online, and anybody can download it and build it. So that's one way where you share the design, like the source code, and people can use it or can modify it, whatever type of license you decide to apply, Creative Commons license you decide to apply. So that's certainly something we can do. But sometimes, if you need to do this building, you cannot think that anybody will be able to do the structural calculations to make sure the roof doesn't fall. There's some things that you will still need to have some experts being in charge of. And it doesn't mean that you can still open source it in different ways, by engaging people at the beginning, by engaging people then in using it and in giving feedback. So what I mean, there's different ways to create these feedback loops. Open source is about creating an open feedback loop that can happen at different levels. And so it's a bit more difficult than with code. With code, you've got a piece of code, and then you can simply modify that. With the building, you've got different phases. When you define the brief, to the end, when you just use the building, you can actually open this loop and get feedback. And as I was saying before, just the very fact of getting people who give feedback, like at the Expo, had 2 million people or some million people who went through the building and left feedback and so on. That was another way to open source the design and collect their feedback and learn from this for the next iteration, of the design. In the same way as we were mentioning before about media, that's another component of how you can have a conversation that becomes a way to debate the design and learn from that and improve it in the next generation. So that's more about the open sourcing itself, which is a bit more difficult than with code, but can happen at different levels in the process. The second point is about should we open source, and I really like this question, and I like this question also because in some of our designs, some of the things we put up, and one of the first things we put open source was like 10 years ago. It was a design we did for the Dalai Lama for tsunami-resistant homes. We developed a design that was much more resistant for tsunami. In that, we put it open source, and people started using it in Southeast Asia after the big tsunami in Sri Lanka around 10 years ago. So it was our first experiment. We put quite a few things in an open source way online, but also sometimes at MIT in particular, we come up with an idea and MIT will patent it. So we got a bunch of patents that then sometimes are licensed or given to others. And I don't think that there is just one solution. I don't think we should be like black or white about should we always be open or should always be closed. If you think about it, in many cases, if you want to open source things, you just want to maximize the impact of an idea. And so I would propose that in general, instead of thinking in a kind of an ideological way about should it be open or closed, the key thing to think about is how can we maximize the impact of an idea? And that can happen in under different paths. And sometimes, of course, the open path can be preferable. In other cases, it can also not be preferable. There's evidence that, for instance, in the pharmaceutical industry, patents are helping to a certain extent the develop in that process. That some things would not happen in the same way if there were not patents. So I think in a certain sense, the important thing is that we're all aligned about the ultimate goal is what we were saying before, is about how can we look at the world around ourselves and transform it and develop it in a creative way. Now, how we achieve that, it can be through different paths. Sometimes be the open or the closed path, but the ultimate goal is, I think, is a measure of impact. How we can maximize the impact of the good impact on the world of an idea. Yeah.
My question is related with how do you see the professional as designer, architects, industrial designers, as with the topic about intellectual property, because this is something that is coming with the new technologies, with the open source information that you are telling to us, for example, the open source design, where the designers, their business is about intellectual property, And many like inventors now in Silicon Valley or in another professions, they are more developing tools, but they are not developing like shapes or another kind of things that they can sell. They are selling the service or they are selling the application. How do you see our profession without intellectual property?
Yeah, well, I think I'll tell you how I would see the profession. I think the profession is in a very interesting situation. By the profession, I mean designer, architects, and so on. And it is, if I were to use Buckminster Fuller's word, it's about utopia or oblivion. And let me say, oblivion means, nobody cares anymore, or utopia that, can actually do something powerful in the world. And I think the reason is that ultimately, if we need to go back to the definition of design I mentioned before. The definition of design is a way to look at how the world could be. If we take the definition of design, the world around ourselves, then there has never been that much need of design as today. It's an incredible time. It's a time where we have, every other week there's some CEO of a big company coming who's totally freaking out because he's freaking out because for the first time on the planet they see that you got a condition where you got companies who went from nothing to masters of the universe back to nothing. Think about Nokia from very little to masters of the universe to now to back to basically nothing in 20 years or 25 years. And so it's the first time that this happens. So really this idea of innovation, this idea of how the world could be, of experimenting with the world, the artificial world around ourselves, that becomes very, very important. And I think if we capture that, then as designers, we can have an incredibly important role in society. We can be the agents for transformation as I said before, the mutagens, and we can propose things that in society can debate, and then can decide to adopt or not, but still we can prompt the transformation of the world of the present. Now, on the other side, there's oblivion, and oblivion means if we just keep on doing the things we've always been done, that's oblivion. If you think about, if you just keep on doing funny shapes in architecture, if you just continue doing, funny shapes in architecture, even if you take today signed by architects, which is less than 2% of the global production that we do on the planet. If we keep on thinking about design as this kind of refined ivory tower activity, then that's certainly oblivion. So I think it's a very interesting time, and if we go back to the very root of design, the future and the transformation of the present, then I think we can really have an important role to play. Thank you.
Thank you for these amazing projects, but I was really interested in seeing the sofa, the development from prototype, which we saw like 5-6 years back, and then it becomes into a real virtual reality platform. And then
did you see it in Milan this year? No,
it's been famous from the last year. It's been on social networks, and it's nice to see as a working prototype on the sofa. But my question is, see it more onto an urban platform of scaling it up, and if it happens, hopefully it happens. And I was interested to see the interface of the user controlling the huge prototype, and if it is being for example, we put a scenario and say it goes on the urban dynamic system, and where does the data come from, and how does the user control it, and who controls it? Just like the Expo, you were talking about the water. It was interesting, and how do you generate the data, or even the urban analysis, the mapping. How does MIT extract the data, and on a static platform or on a real-time platform? How does the workflow happen?
Yeah, it's a very. I'll try to answer in a more philosophical way, but it's really about data, and data is the way that we interact. When we're talking about sensing and actuating, a lot of that happens to flows of data information. If you think about us, when we talk to each other, we sense each other, we look at each other, we collect information from each other, and then we respond to that information. It's flows of data. If you look at how our brain works, if it's all the same thing, if I try to pick this bubble, the way the brain works is very interesting. It's actually, as you move this hand, your brain constantly gets information from this point, measures the difference from them, and keeps on realigning. It's like an intelligent bomb, guided bomb, the same thing that today's intelligent bomb that follows and adjusts in order to hit the target. Our brain does exactly the same. As a matter of fact, the intelligent bombing system was developed initially by the father of cybernetics. All of this is related to cybernetics, who was Norbert Wiener, and who actually was looking at some of these problems in trying to use how the brain works in order to solve problems that you could use outside in the real world. Now, if you look at this, so data is the flow of data that we are collecting and we're sending back is vital in order to really create this kind of feedback loops. And you have it in many different dimensions. Now, on the sofa, I will not comment, is more like something we did to create an interactive experience. You can find the interface you were referring to, you find it online, you can play with it, actually we put it online on the website to play. But from a more general point of view, really data becomes this ability to create these feedback loops, and the analysis of data using artificial intelligence on the data streams, using in real time different type of analysis on the data can become very, very important in order to change the interaction we have between us and the environment. And that's exactly what our brain does. It gets data and processes the data in the same ways as you would do it in the city. Now, because of this, I mentioned before, I didn't show it, but I mentioned before the project we did with sharing mobility. I'll show with you just a couple of slides about that. That really deal, in this case, about data and how we use data to discover something in New York, and that something then led to an interesting application. So I'll just 3 or 4 slides. But basically, I showed you before the fact that today we have a lot of data from taxi. And what you see here is actually New York, and you got taxis, pickups, and drop-offs. So every yellow dot is somebody who jumps into a taxi, and the blue dot is somebody who gets off a taxi. What you see here is the JFK Airport. For those of you who know New York, you see all the terminals. You zoom out, this was JFK Airport. Here you see all of Manhattan and the boroughs and all the rest. And then we asked ourselves, what if people could share mobility more? Now, we know that today we like to share a lot of things, even intimate parts of our lives. I think about Airbnb, rooms on Airbnb, on couch surfing platforms. So what if people were ready to share mobility more? Well, the potential is quite significant, because if you take any 2 points in Manhattan, you got hundreds of thousands of trips connecting them over the course of a year. So when you got this was a huge amount of data that was shared by Mayor Bloomberg. Actually, Mayor Bloomberg, going back to your point about data, had a sign in his office. He built an empire. His personal private, his company empire is built on data. So he had a sign in his office that said, "In God we trust. Everybody else bring data." So data becomes really the thing in order to understand what is going on. And one of the things he did while he was mayor was actually put a lot of data open so people could analyze it. So we took the data in New York and we started analyzing it. Now, when you do this, sometimes big data needs big mathematics. So big data might need new mathematical approaches. So in order to do this, that's a paper we did. It was last year. We analyzed all this massive amount of data in New York in order to answer the question I mentioned before about shareability. If you want, the question is, imagine you want to take everybody to destination exactly when they need to be there, give or take a couple of minutes. What is the minimum number of vehicles that you need to have? Well, we did this using this shareability network concept, which is basically building networks of how trips could be shared. And what we discovered was quite extraordinary, that basically in New York, you could cut 40% of the fleet of the taxis and still take everybody to destination when they need to be there. Now, this was an example of how data help us to understand something about the city. The interesting thing is that some of these results, the paper is from last year, but the initial results came out before and came to the attention of Uber. And actually, we since started collaborating with Uber. And as you might know, Uber Pool does exactly that, allows 2 trips to be shared. And I think Uber Pool, we're very happy, just reached like 100 million trips, which means, it's 100 million cars you're taking out of the road. For that trip is a lot pollution less, is a lot of congestion less in the city, just because of the ability you have to share with somebody else. And plus, in addition to that, we have a follow-up paper that's coming out now, which is also about the potential to meet somebody on that trip. That's quite fun as well. You can meet interesting people on the trip. Somebody put it like it's a blend between Tinder and Grindr and Uber, and you combine the two, and you get interesting results out of that. So anyway, so that's about showing. But data is really the glue that allows you to exchange information and create feedback loops with space.
Two quick questions. One has to do with one answer that you gave before. You were doing a parallelism in between the mutation as a manner not to improve.
Yeah.
We know that mutation in this parallelism with the theory of evolution of Darwin, we know that has been a manner that took thousands of years to produce any small novelty or improvement. I would like to know how could you speed up this process without coming back to the totalitarian figure of the architect of the 20th century.
Yeah, it's a great question, and I think you want to push this analogy between the natural and the artificial world up to a certain extent. And but this analogy is something that was proposed already in the early days of evolution. In the 19th century, there is a guy called Butler. And Butler writes this essay, which is called Darwin Amongst the Machines. And what he does in this essay is really look at, it's quite funny, the way he looks at things from the point of view of the evolution of machines. And actually, he sees machines as things that are reproducing themselves, using humans to reproduce themselves. Now, beyond Butler, many people have looked at this analogy between the evolution of the artificial world and the evolution of the natural world. And you can really find many analogies in between the two. What you're getting to is actually quite interesting. because it's about the randomness of mutation in the natural world versus the directedness of mutations in the artificial one. We tend to do one of these mutations, if you look at try to modify a city, we'll try to do in a way that we think that will be a successful mutation, while the idea behind Darwin's evolution theory is that that mutation will be more like a random mutation that will be selected. I want to say, however, two things. So there's this difference between the two. However, there's two components. First one is that the latest studies on DNA show that it might well be that in natural evolution, there's much more directedness than what we imagine. And basically, it would be, if you think about it, also it would be a very silly system for nature to have a totally random mutation, right? If you need to come up with a beaver who knows, I believe that the beaver knows just if he's born and by itself, he knows that he has to build a dam, how to build a dam. Now, if you had to do this in a natural way, with totally random mutation, it would be a very inefficient system, right? You need to have many mutations. You have a beaver who spends the whole day sunbathing, and the beaver who spends the whole day chit-chatting, and one that spends the whole day building a dam, and that gets selected and is more successful. Now, it doesn't make much sense. So I think the latest studies with DNA and on evolution using genetic techniques seems to show that there's some directedness in that process. So it's a process which is more Lamarckian than Darwinian is a basis. So that's the first thing. So maybe they're not too far. But yes, that difference is really, I think, what makes a good designer is probably a mutagen, which actually can produce a mutation that has more success. I think the reason that perhaps Steve Jobs was a good designer is that the mutation that he did, assembling existing pieces and just combining them in a different way, changed the life of billions of people on the planet and was widely adopted. While other mutations that we've seen were really things that were abandoned, and so they were kind of failed mutation, even if they tried. So somehow, what I'm saying is that intentionality, that thinking about doing a mutation that is successful is important. It is different than natural evolution, even if in natural evolution it looks like there might be more intentionality to what we used to assume just in the past. And but at the same time, many other things can be seen as similar and common.
It is true as well that in all humanity, probably we have different directions. No, not the intentionality is not a same whole, which is the same whole following the same direction, but probably we can. Eventually, it can be opposite.
Yeah, as nature does, but in a certain sense, it's not a totally random process, but it's a process where you somehow want to have a mutation which is somehow successful.
Okay. And second question, I see technology as a capital point, in your work. I would like to know if your work, your projects, your ideas are a reaction or a consequence of technology, or on the contrary, your works, your ideas are pushing technology in a certain and particular direction.
I like to think that actually our projects don't deal much with technology, but we like to think about the human side, whatever it is. If it is about how you can interact with the bottle of wine in the supermarket, and then you might want to use new technology to try that. But I think, ultimately the starting point or the ultimate goal is always something human. And I think that many times people make confusion between, what technology is. I think the only technology that's meaningful is the one that changes our life. If you think about Facebook, it does, we were saying it before, it does, what we've done thousands of years ago just by going to the well and gossiping with each other, what we've done hundreds of years ago by writing letters and updating each other, what we've done 50 years ago by calling each other. It was very inefficient. You break up, you need to call somebody, and then somebody calls somebody else. Now you can do it in a much easier way, but it's the old same thing. And so in a certain sense, I think the ingredients of architecture are always the same. It's about the magic of space, the magic of light, of interacting with each other, of the sociable spaces. But if there's a technology that can help you to do that, that's more than welcome. And so we try to use technology to enhance some of those things which are really timeless. They're not technology-based. I wanted to add another small point about the fact of mutations. It is true that you want to do you want to have mutations that have an effect. In some cases, in most cases, you want to do mutations that have an effect because they're widely adopted. In some cases, however, you can also think about mutations as a way to start a conversation about where you don't want to go. As we said before, a mutation is something like a new design that you propose can also be something that allows you to have a conversation about something that is a path where you might not want to go. When we did the real-time Rome project that I showed you before, the monitoring on cell phone in Rome, we knew that that was very interesting. It was the old dream of generations of urban planners to see the city with all the flows inside it. It was also scary. It was about the world where you could track anybody over there. And we, that for us was important as well. If you want, somehow there's an analogy which is with hacking. With hacking, you've got white hat hackers and black hat hackers. And white hat hackers are the ones who show a problem, a vulnerability of the system, so that people can fix it. So when thinking about those mutations, we don't need to think only about mutations that can have an impact because they will be widely adopted, but sometimes also about things that can help us do the same of white hat hacking, basically developing antibodies so that we don't go in that direction. We stimulate a discussion about something where we don't want to go. Not only where we want to go, but also where we don't want to go. So somehow in this feedback loop we are talking about before society responding, then this becomes an important component as well. Yeah. One more question.
Thank you, Carlo, for your presentation. I was thinking, because most of the work that you saw today, but also most of the things that you're writing about, is related with this idea of alive, no? The life matter, the interactive alive buildings. Same with the urban scale. And of course, today, the majority of the technologies that we have are technologies that they are basically programmed or hacked by us, designers or programmers or a group of people around those codings and scripts. And then it's becoming actually very controllable, no? Because you know how the performance would be. You know when the water should go up or down. You probably don't know the data, but you know how the performance is going to let's say, take place. So my question is, should we, or are we as designers, ever let this control out of our hands and allow a kind of a more real evolution, talking about mutation and evolution and adaptation, better said, a step further than adaptation, will we get into that evolution, like allowing self-organization, self-programming to happen, and design to surprise us?
It's a great question. Now, I think there's two components of the question. I think it's a great question to finish. I think there's two components here. One component is more the fear of singularity. I mean, can we really let machine program themselves become, create another ecosystem, even with the risk that this ecosystem can actually get rid of us? And that's the fear of singularity. It's a fear that's been there forever. You find it over and over again. Is something where my positive thinking here is that somehow machine and humans are going to be stronger than just the machine. But hey, I think we can also be post-humanist if we're going to really build machines that are more efficient, more intelligent, better than us, and can be much smarter than us. They have the right to take over. So it's okay that also we close the door and we let them continue. There's an interesting article by a guy I respect a lot, who's the Royal Astronomer at the University of Cambridge, a guy called Martin Rees, who did this article in the Financial Times just a year ago or something about the fact that electromechanical intelligence is much more powerful than organic intelligence. Organic intelligence, if you need to ship this type of intelligence to another planet, we couldn't, just because of the difficulty in time. It doesn't live in long enough, but electromechanical intelligence could do it, could actually go expand in the universe. So his point was totally post-humanist about, that's much better, so it has the right to take over. But that's for the first part. So for the first part is about, about machines starting to reprogram themselves and regulate themselves and in a certain sense, become an independent ecosystem that could also then fight against us with this old fear of singularity. And but the second component I want to say is a bit less scary, is more about serendipity. What you're saying is that today we're programming things in a way that we know from the beginning how they will react. And I think here there's something important that even without going all the way to machine that self-programs themselves, we need to make sure that in the things we program out there, in the space outside, there's still serendipities. What I don't like is what Amazon does today, right? It tells you, okay, use just what is called predictive analytics in order to say, you've read 10 books, and here's 11 you want to read. Well, I'm not interested in that at all, but I'm interested in that 11th book that has nothing to do with the other 10 books I've read, but actually can totally change my life. And I think that's what we need to always to pay attention to, about how we can program things that create more richness, not less richness, more serendipity, no less serendipity. And you know, serendipity, I mean, serendipity is a beautiful word that only exists in English. It's difficult to translate in Italian. I don't know in Spanish. How do you call it? Does it have a translation? But you know the story about serendipity is about this story, I believe, of the king of serendipity. One of the things to actually, serendipity is about finding what you're not looking for. And, you know, and this guy, serendip, goes out to look for something, but on the trip doesn't find what he was looking for, but finds something else, which is, it's even better. I think we should always keep serendipity in what we do as designer. Thank you. Ah, no, perché super, me l'ha fatto le foto. No, perché sto facendo le foto con quello dell'avanguardia. C'è un pezzo che pelava.
Hey, love your talk.
Thank you.
Hey,
man, let me just say hi.
Okay.
Hey, man. I know, I think
You printed all that.
what do you do now?
I work with like a startup. I'm also seeing here to double check your property.